All right, welcome everyone. As Lisa mentioned, my name is Pat Hoppy. Um, I am recently retired, so you may hear me say present tense, past tense when referring to teaching. I retired in April, so it was a wonderful career that I absolutely loved. And for all of the teachers in the room, um, I would say congratulations and thank you for doing what you do. Um, I became an engineer primarily because of several key teachers throughout my educational career that spurred me to go on. And we can make a difference in people's lives. So thank you for teaching. Um, I do have my contact information here. If you have any, if after this is over, you have any questions or you want further clarification, you can reach me via email or you can reach me on my cell number. As Lisa mentioned, I am a co-author on two books, Digital Electronics and Electronic Principles. I was really excited to become co-author of the second one, Electronic Principles, primarily because when I studied for my associate degree back in 1983, I used the second edition of Malvino's book in my first analog class, and that kind of set the tone for me. And to later become a co-author of that book was pretty spectacular for me. I taught for many years at Gateway Technical College, and I was their division chair for all of those years. And wearing two hats was an awful lot of fun. Now, in addition to these two books, I do have a list of books that McGraw-Hill has Multisim files in, and we'll get to that in a minute. But I have a question for you all. So just so I get to know my audience a little bit, from 1 to 10, or excuse me, 1 to 5, how familiar are you with using Multisim? 1, you've never used it. 5, you've used it for years. Could you put that up in the chat window, please?
So Pat, I'm not sure if you can see the chat, but so I'll just let you know. It looks like a mixture. There's a bunch of 5s and 1s, so people have never used it, and then there's a people are familiar too, so it's really across the board. But there are people on the call that have used it for many years.
Okay, excellent. Well, I think you'll find something for everyone here. I really tried to set up a presentation that way. So great. So now I know my audience. I appreciate you doing that. And also, if you have questions along the way, certainly type them in the chat or just I'll turn on your audio and let me know. I tend to prefer that versus waiting till the end. And Lisa, I don't have my chat on, so if you see something in the chat, please get my attention.
Absolutely.
Right. So what is a multisim? Well, it's a SPICE simulation with a very user-friendly interface. When I first started using PSpice many years ago, it was a text-based program that ran on a DOS computer. I'm seeing some head shake. You're I'm as old as I am. You fed your file in, you went away and had dinner, and you came back, and if you're lucky enough, it was done, and hopefully it worked. It's really evolved since then. Multisim has a graphical interface. You are able to get a site license for your campus or for your school if your school has multiple campuses. Where I taught, Gateway had 3 campuses and 5 technology centers. We purchased a site license that spanned all of them. What I really liked about that was if the school owns a site license, you can give a copy of the software to the students to install on their computers at home. And they're able to install it, and it's good for a year. And then after a year, they have to download the student edition again, and they get another year, and that's free. And then you can also buy an individual student version. We sold those in the bookstore for years. I have a link at the end of this of where you can go to get it if you're interested in that. I believe the student edition is $54. We made it part of the course. So when the students bought their textbook, they also bought a student edition. And that way they could use their financial aid dollars for it. And our students liked it because they could work on things at home instead of driving in. And if you can save a few trips to campus by having some software at home, it was worth the $54. Now they can get it for free because of the college where I taught had a site license. Another thing you can use Multisim for, besides a circuit simulation, is it's also a great environment for the students to practice with test equipment. Multisim has generic test equipment, and then they also have several pieces of virtual test equipment that look like the actual devices. And I have some pictures coming up. So when I was teaching students how to use an oscilloscope, I would put the Tektronix oscilloscope, I would project it up on the whiteboard and walk them through the controls of it. And then we have the exact same oscilloscope at each station within the lab. So the students could practice in Multisim, and then that would carry right over into the actual hands-on labs. The other thing that I used Multisim for a lot was to create schematics. The hardest class in all my years of college was a lousy 2-credit graphics class I had to take back in sophomore year of engineering school. And I can't draw to save my life. So I struggled in that class forever. When I discovered that I could make all my schematics in Multisim and then copy and paste them into my Word docs for my exams or into homework assignments, or I'll show you how you can put them into Connect and create your own questions in there. That was an absolute game changer for me. I wanted the work that I gave my students to look professional because I wanted to set the tone for what they turned back into me. And I taught them how to draw them in Multisim also. So when they submitted schematics, they were drawn in Multisim and then using a screen capture tool, pasted into their Word docs for their engineering reports. So I really like it for drawing schematics also. Now, how many books use a Multisim in the McGraw-Hill collection? Well, there's 5, and I've created Multisim files for all of these. I've been doing this for years for them. In the textbooks, in all the examples, or in all the examples within the textbooks that have a Multisim associated file, there is a special icon next to it. So as you're going through the book, if you see an icon that says Multisim, there is a file that you can open up and run the simulation of that example. I really like that because I am an active reader. So if I could be reading through a chapter and I get to an example and I can open up Multisim and have that example demonstrated for me, it really meant something. So we incorporated them in the textbooks and then also into the experiments. And I have an example coming up here of how we actually incorporate Multisim into the experiments. All of these have associated Multisim files that you can download from the instructor resource area for the particular book. I've also written a primer on how to use Multisim, and that's associated with each of these books, and it's geared toward whatever the book is specializing in. So when I wrote it for the digital book, I used all digital circuit examples, and I talked about the instruments within Multisim that you would use in a digital course. The same thing when I did it for the Grow Basic Electronics book. There I use DC and AC circuits, and I use examples where we're using the oscilloscope to measure phase shift. So the primers are written toward the subject matter of a particular textbook. and they're
Pat,
available. Yes.
oh, I'm sorry. There's a question, and it's probably timely with your mention of the primer that you have. John Croft is asking how many hours to train students on Multisim, to use Multisim.
Sure. So I would say less than an hour. And I would say probably closer to 15 minutes. And let me explain why I'm saying that. Multisim is very much like Word. The first time you used Word, you figured out how to save and print. And then the next time you used it, you learned how to underline and boldface and maybe create table of contents. Multisim is very much the same way. I'm going to show you a few screenshots coming up that if you do these two things, you can create a circuit and you can run your simulation. So I found that by giving students 15 minutes of a presentation in class, having them take a few notes on just a few key button presses, they can create schematics and they can run simulations. So less than an hour, and they'll be creating their own. What we did, truthfully, for labs, for the first semester students, I gave them all the Multisim files. For second semester students, I gave them all the Multisim files, and about half of them didn't bother using them. They created them themselves. By third and fourth semester, they were creating all their Multisim files themselves. It's a very quick learning curve. And I think you'd find that if you spend 15 minutes demonstrating it on a board, so we had projectors in the room where I could project my laptop up on the whiteboard, and I walk them through using it, 15 minutes, and they're off and going. So it's very quick. Did I answer your question?
Yes. Likely. There's one more question that is asking, would you use it for students in basic electricity, for students who don't know anything yet? Sure,
John. So I taught at a 2-year technical college, and we introduced them to their very first semester. They take a DC and an AC course, and the very first week of class, we get them doing something in the lab, because our take was we wanted them doing something in the lab hands-on every week that they were in school. And so we introduced them to Multisim right away, and how we used it was to teach them meter placement for when they're measuring resistance, or they're measuring current, or they're measuring voltage. And teaching them to do that with an instrument in a Multisim is a lot less scary for them, because otherwise they're burning out fuses. And then they don't want to burn out fuses, and they don't want to hook up the meter because they don't want to be the person that burnt out the fuse, right? So by us teaching them how to place the meter to measure current or to measure voltage in Multisim, it's not going to burn out a fuse. And they get some practice there. So yes, we use this from day one. A first semester, first week of class, and these folks walk in and we assume they have zero knowledge, and we build from there. So yes, it works for them. Okay, and you know what? So I'm going to show you an example on where your industrial students may want to use it, and I've got that coming up. So I'm not sure if you use this feature of it, but I will. We'll get there in a second. Here we go. All right, so this is what the Multisim screen looks like. And I'm going to close the chat window for a minute so that I can see the screen. And the white area in the middle, for those of you that haven't used it, this is where you draw your schematics. The icons along the left-hand side are all of your instruments, all of your pieces of test equipment. And then the icons across the top, as you click on them, it opens up different groups of instruments. The very first two are the ground symbol and the resistor. The ground symbol is for all of your sources. The resistor is the icon for all of your basic components, and I'll show you those in just a second. You mentioned that you have industrial students. I taught an industrial electronics class. It was in our EET program, and in there we taught them a ladder logic. Well, did you know that in Multisim, you see these two icons here? You can draw a ladder logic circuit in Multisim, and then you can simulate it. Upper right-hand corner of the toolbar, if you were to click on that, you can draw ladder rungs, and you can put in contactors, you can put in switches, and I would have the students draw different circuits in ladder logic. Using that, they could simulate it in Multisim to prove to themselves and to me that it works. And they learned ladder logic there. So when they took their PLC courses, then they came into their PLC courses with some basic background in ladder logic. So you may want to check that out in a Multisim for those students. Okay, so you're using Automation Studio for ladder logic. We use Automation Studio also for our PLC classes and for our hydraulic pneumatic classes. But you can certainly use that for your ladder logic. Yeah, but if you only have Multisim and you don't have Automation Studio, you can draw the ladder diagrams in Multisim. All right, so I mentioned that with just 2 button presses, we can draw a schematic. So the very first one opens up the sources, and the window you see here in the center is a list of sources. Now, for those of you using this for DC and AC circuits, if you want your voltage source to be an RMS, you want to choose power sources and AC power. If you want your AC source in volts peak, you can choose signal voltage sources and then choose the signal AC one up top, and that will give you your AC source in volts peak. It's one of the areas students get confused on, because they'll find the AC source and one day it'll be in volts peak and the other day it'll be in volts RMS, and they're not sure how to switch it. It is actually 2 different sources in 2 different locations. The first one is in power sources. AC power will give you everything in volts RMS. Multisim does all their simulation using a nodal analysis type algorithm. So in order to do your simulation, the circuits need to have a ground. So you'll see the digital ground and then the standard ground here. When you build your circuits within Multisim, be sure to include at least one ground, because it will use that as a reference point. So if I was building a DC circuit, I would choose DC power. It would give me the battery symbol, and then if I click the second icon and scroll down to resistors, when I click on resistors, it would give me a list of resistors to use, and then I could pick the value I wanted, and it would put it right in. Now, if you're impatient like I am and don't want to scroll through the list, choose the default that comes up, and then when it's on your screen, double click on it and you can change the value. I found that to be quicker than scrolling through the screen. What I do is I just paste one on, or I just put one on, and then I copy and paste multiple ones and change their values. So this is an example then of a circuit that we could draw. I have my DC source. my 2 resistors. And then I would use something like this to demonstrate meter placement for an ammeter. This is the generic multimeter within Multisim. And then voltage measurement with the virtual adjuvant multimeter. Now, I like this because this is a face of an actual multimeter. In order to use this, you have to press the button to turn on the power. You have to select a DC volts. And then depending upon where you hook up the wires on the connectors here, you'll see the little white circles over here on the connectors here. So it gives the students that hands-on feel that I've actually hooked up a multimeter. We would demonstrate something like this that first week of class, just meter placement. And we do that because our DCAC students, as part of their first DCAC class, they get a snap-on multimeter. And the fuses for those are $5 a piece. And we give them their first one, and after that, they have to buy them in the bookstore. So to save those $5 fuses, we teach them a meter placement here, and then we teach them to use their snap-on meters, and then hopefully there's a lot less fuses being burnt out. So this would be an example of a simulation. And then to actually run the simulation, there is a green arrow here. It is now grayed out. If you click on that, it will start the simulation. And to stop it, you can just click the red arrow or the red square. You will not see the readings on the multimeters until you've started the simulation. Okay. If you're teaching an AC course and you're doing a phase shift, then you can demonstrate that with the Tektronix oscilloscope. I like this one because we had scopes, we had the exact same model of the 2024 at all of our lab stations. So if I demonstrated how to use this oscilloscope using Multisim, they could take that right back into the classroom. And all the buttons work, all the dials work. To turn the dials, put your mouse cursor over the dials and use a roller wheel on your mouse, and that'll turn the dials. It's a lot easier than holding the mouse button down and trying to drag the dial. Use the roller wheels on your mice. Here's a close-up of that screen, so you can see they had taken the exact image of the Tektronix scope, of the 4-channel scope, and built it right into the simulation. So this is a real nice way to teach students how to use an oscilloscope. And even if you don't have the Tektronix scope, you also have an adjuvant scope. But even if you don't have either of those two, we all know that oscilloscopes work basically the same. So you have your time base, you have your vertical section, show them how it works, and then they can transport that over into whatever model you have on campus. Now, in addition to this, one of the things that we taught in our second year was we talked about low pass and high pass filters, and we taught transfer functions. Well, if you created a bode plot, when I was in school, we used a function generator and an oscilloscope, and it took about 3 hours because you had to keep adjusting the amplitude of the input signal and taking all of your data points. Multisim has a virtual instrument called a bode platter. And what I like about that is what it does, you put an AC source in. It doesn't matter the frequency or the amplitude, you just need an AC source. Put in your resistive component, and in this case, I have an inductor, so I was building a high pass filter. And it will sweep this AC source. You set it up, I had it set up from 1 hertz to 1 megahertz, and it swept it and generated the bode plot in about 1.5 seconds. So when you are demonstrating low pass and high pass, band stop filters, for the students to see relationship that with these two components, if I swap their position, this circuit becomes a low pass filter. So they learn very quickly that location determines type of filter, values determine the corner frequency. And you can demonstrate that real easily within Multisim, and that works out very well. If you are lucky enough to have the National Instruments Elvis units, I don't know if anyone has the Elvis units. Elvis has the virtual bode plotter built into it as well, and we use those in our second year classes. And you can actually use real resistors and real. Okay, great. So you got them on WCTC. I love the Elvis units. You can do the a bode plotter on there as well. And MyDAX, yes, I'm very familiar with those. I have a MyDAX myself. I keep asking for an Elvis unit for Christmas, but my wife doesn't hear me. I don't know. All right, we'll keep on going.
Pat, do you have any comment about, Andrew Bell mentions the equipment that we use may not match the ones currently available from National Instruments? Just wanted to point.
Sure. So like I said, they just have the adjuvant multimeter, and then they have generic multimeters. They have a generic oscilloscope, and then they have the adjuvant oscilloscope and the Tektronix scope. They don't have a wide range of different manufacturers for scopes. We have schools in our district, high schools, that also teach our DCAC class as part of transcripted credit, and they don't have the Tektronix scopes there, but they still use Multisim. The instructor still uses Multisim and the Tektronix scope to demonstrate how you adjust the volts per division for the amplitude and the seconds per division for the time base, and how to measure phase shift, and then shows them on the Tektronix scope, and then he walks over to their scopes and says, this is where you adjust it here, and this is where you adjust it there. So it's almost like if you learn to drive in a Toyota, you could jump into a Ford. You might have to find where the turn signal is or where the windshield wiper button is, but you're still going to be able to drive the car, right? So I think it's very much the same with test equipment. In all the different places I worked, my background is biomedical engineering, and I worked as a biomedical technician for many years while I was going to engineering school. And I worked at many different hospitals, and each one had a different manufacturer of test equipment. And I was able to use all the different scopes because once you learn one, you can transport that over. Now, in the traditional approach to lab experiments, we'd have our students do the calculations, whether it's on an engineering logbook or some graph paper, and then we have the students build the circuits on a breadboard. They measure them, and they compare their measured values back to the calculated. I would propose that we add two more steps. The way I taught lab is I had the students do the calculations, and then I had them run the simulation, and I had them check to make sure that their simulations matched their calculations. Then they had verification that what they calculated for current was do we use Labview? We did. We did in an industrial class. We're not currently using it now. Right. We use the NI Elvis MX launcher. Yes, absolutely love that. So, a biomed tech for 13 years. That was next to teaching. I loved being a biomedical technician. For those of you that aren't familiar with that profession, we fix medical equipment. If they use it in the hospital on you or to help you get better, we used to fix it. So it was a very cool profession. Okay. So we do the calculations, we do the simulation, and when the two of them match, now they are confident that they know what the current, the voltage drops, what have you, are correct. Now we're going to have them build a circuit where they're going to measure, where they're going to actually build it, measure it, and then record the data on the experiment worksheet in the experiment manual. At that point, I have them go into Connect. We use McGraw-Hill Connect for all of our classes, and you can assign lab questions where it asks them questions about what they did in the lab. They input their answers or they upload scanned tables, and then it can be graded, and then you can look at the scanned tables later, and I'll show you an example of that. Now, for the calculations, we started doing something different than hand calculations. We used Mathcad. I started using Mathcad back in engineering college, back in the early or late 80s. It's come a long way. We use it in all of our classes at a Gateway. For those of you that are not familiar with Mathcad, think of it as a free-form spreadsheet where you define variables up top. I defined variables here, VCC equals 10, R1, R2, RC, RE. You can put in units. And then if the students create the appropriate formula, it will solve the formula. It doesn't give them the answer for them. They have to put in the right formula, but when they do, you can then hit equal, and you'll see that on the next page, and it will solve. Now, I mentioned earlier that I use Multisim to draw all my schematics. I drew this one here in Multisim. I use a program called Snagit from a TechSmith. It lets me do a screen capture. I can edit it if I want it. You could also use the snipping tool within Windows, paste that schematic right into Mathcad, and now you can see the circuit that you're going to analyze. I created my formulas. It lets you add in text. I have my students put in text to explain what it is they are doing. And all of this would fit on a single 8.5 by 11 sheet of paper. If they're doing this in the lab, I have them print out their Mathcad sheet. So when they're sitting there next to their breadboard, they have all their calculations in front of them, along with all the answers. And what I like about Mathcad is, although we have a 50-seat license at Gateway, Mathcad offers a free version. It's called Mathcad Express. I have a link at the end of this. You go in and you download the full version of Mathcad. Your students can download the full version of Mathcad. And after 30 days, it reverts to the Express version. It will have almost everything you need. Well, it'll have everything you need if you're teaching at a 2-year college. What it will do is put a watermark on there that says that it has a Mathcad watermark on there. But other than that, it is free. So your students can use this at home for their calculations. I like it because it forces them to learn the formulas and recognize them. So if they're solving for emitter current, the voltage across the resistor divided by the resistance. And then when you hit equals, it solves. And if you've used the units for them on a previous page, the answers come out in the correct units. So I just thought I'd share that with you. If you're not using Mathcad, you might want to take a look at it. All right, so then they've done their simulation, and they now have their calculation. They can check their simulation against the calculation and say, okay, I'm reasonably confident I've built the circuit correctly and I've hooked my meter up right. Now that I see that I've hooked my multimeter up right, now I'm ready to build my circuit. And then I can take my measurements. So for my students for the last, we've been doing it this way for the last 5 years. A calculation, simulation, and construction. Actually, I shouldn't say 5 years. I started using electronic workbench in 1999. I switched to Multisim in version 1, and I've been using Multisim since it came out. So I've used every single version of Multisim. So our students have been doing simulation and then construction and measurement since 1999. And I really see all three of these as 3 legs to a stool. I want them to calculate. I want them to simulate to verify their calculations. And now that they know that that is right and that this is how you're going to take your measurements, then I want them to build. And all 3 should be should give them the same results. Now, I said that we incorporate this into our experiments. Well, what if you don't want to use Multisim? I'm just saying, or you don't have it within your on your campus. This is an excerpt out of the digital electronics experiments manual. The procedures on page 36, and the table came from page 37. If you notice on step 2, how I write these into the experiments manual is I put the Multisim as an option. So you as a professor in the room has the ability to say, I want you to do Multisim for this particular experiment, and it walks you through what it is you want them to do. It also tells them the circuit file that they can open if you've shared them with them. And you can have them do that step. Then in all of the data tables, I have a for digital a predicted outcome. In this case, they're learning about AND gates. So I asked them to predict if you have 2 logic zeros going in or 2 logic lows, what do you expect to get out? And I have them predict, and then I have columns for Multisim simulation as well as actual. And all the data tables are set up that way so that if you use Multisim, you have it listed on your data table. If you just use hands-on, it's listed on the data table. If you use both, it's in the data table. When we transitioned over to online teaching a year ago, March, like all of you did, we didn't have lab equipment to hand out immediately. So we did Multisim strictly for the first month or 2. And then we were able to get test equipment out to them. So we were doing just Multisim. Then we were able to bring in test equipment. So for online delivery, or if you're doing it in the classroom, you can do all 3. All right. I mentioned that we use a Connect to upload or to ask questions about the experiment. One of the things you can do within a Connect is you can ask them a specific question where they have to give you a numerical answer or a multiple choice answer or even a short answer. You can also ask them for scanned PDFs. So what I like to do is when they fill out this particular table in their experiment, within the Connect for this, I have them upload that a table to me so that I can take a look at it and I can see what they got on their lab experiments. I really loved teaching. I hated collecting work and handing work back. If there's one thing I didn't like about teaching was carrying around all the lab assignments and homework and whatever and trying to hand that back to people. I loved being able to have people scan things to PDF and upload it online where I can look at it. We used a Blackboard at Gateway. Blackboard interfaces with Connect, so I could open it up within Blackboard, assign it a grade, and I never had to handle a sheet of paper or hand it back to students. We can also put in questions within Multisim, and we can draw schematics in. We can put questions into Connect about the experiment, and we can draw the schematics in Multisim and put them in as an image, and then ask questions about that schematic image. You can also do drawings and put those in as images for your 4 answers. So you could ask them, which of the following circuits is a common emitter amplifier? And you could have 4 different circuits in your 4 answers, and they could pick the one that is a common emitter amplifier. So you can put images in both the question and in the answers. And although within Connect, there are some canned questions or questions already developed for you, you can also create your own questions. And I have a question for you in a minute here. Well, I'll ask it now. So if there is interest, we may do a webinar on creating questions within Connect. And I would also be open to doing a webinar to teach people how to use Multisim. So if that's something that you'd be interested in seeing, please let Lisa know. But we could do one on how to create questions within the Connect assignment and bring images in and so forth. I've been using Connect for the last few years and absolutely love it as a way to, I'm incorporated into Blackboard, and it just works seamlessly with a Blackboard. I used to create all these questions within Blackboard, but then I had to recreate things. It seemed like I was always working on them within Blackboard. I love being able to pull them right out of Connect. So I mentioned that I'd walk you through quickly how to bring a graphic into Connect. So let's say we had this circuit here that I wanted to bring in. I would use a screen capture program like Snagit or the snipping tool within Windows. I would capture it. The key is you need to save it as a JPEG. Then when you go into add assignment within Connect, you choose create a question. Over in the right-hand corner of the screen is this. You can either select a question from one of the pre-made questions, or you can create one. When you choose create, it opens up a question, the question editor, and there are several tabs across the top. The one on the right-hand side says Media tab. It says Media. If you click on that, you can now upload that JPEG that you saved on your hard drive up to the media collection for your Connect. And then when you're in the question editor, you can pull that in. So in order to use an image in Connect, you need to upload the image to Connect itself. And then once it's in there, you can use it over and over again. So one of the things that I like to do for homework assignments is I might have a circuit like this, but not put in the resistor values. Then I can use the same image, and then in the question, I simply list R1 equals 1K, R2 equals whatever, right? Use the same image over and over again, and then have them practice a series parallel circuits. So it's a real easy way to bring a schematic symbol in. And once it's in, then you can also, like I said, use it on multiple questions. These are the links to the various places that we had talked about. McGraw-Hill higher education. National Instruments makes Multisim. There's an educational version, and it lists all the information on this link. And I believe Lisa will be sending the PowerPoints out to all of you. So you can go out and visit the Multisim site that talks about what comes with the educational version. I have a link to a Mathcad Express and also a snake up by TechSmith. Yes, there is an online version of a Multisim. Let me bring that up. So how about online Multisim? You know, okay, I'm usually not, I usually am not at a loss for words, but I wasn't a fan. I tried it. I wasn't a fan. I like having the software on my computer because I'm not always someplace that I have Wi-Fi, and to be honest, for my students, Gateway Technical College is in southeastern Wisconsin. We have large areas of that part of the state that do not have internet yet, and the students don't have access to internet unless they're on campus. So if we were to use something that was internet based, I would leave them out. I know it's one of those things where we have a lot of farm community and they just don't have cable there yet. They don't have internet. So we stayed with the a computer based. I did look at it because I thought, well, that might be an option for us. And it just, because it was internet based, we just stayed away from it. I needed something students could download on their computers. The college even had Wi-Fi hotspots that they could loan out. The problem was some of them were in areas where they didn't get a cell signal. So unless they drove to a Starbucks or something like that, they weren't able to do their homework. So we just opted to have the software installed on their computers. All right.
And I can grab the chat after you're finished with your presentation too.
Okay.
Just share some of that, yeah.
Okay, and so just in wrapping this up, I wanted to explain how I use Multisim, how we integrate it, give you some ideas on what you might want to do for calculations with Mathcad. I like the paper and pencil, but quite honestly, a lot of times I had difficulty reading my students' penmanship. So when they were putting it in, and I think they had trouble reading it too. So when they started putting it in Mathcad, it was easier to read. It forced them to organize their thoughts. I showed you how we can use Multisim to create schematics, and then I use those in Word docs to create exams or to create homework, even to make PowerPoints. When I create PowerPoints for all these textbooks, I use Multisim to create all of my schematics. I don't use AutoCAD. I don't use any of the other drawing programs. Everything's done within Multisim. So, okay, sure. So the student version of Multisim does have some component limits. It also has a limit, you're absolutely right. It also has a limit on the number of components they can have on the screen, and I think it's 30. But to be honest, none of the circuits we build in our associate degree programs have more than 30 components. So we never ran into that limitation. And in the courses that I taught, I was able to find everything within the student version. But yes, the student version does have some things left out than the full educational version. So, and if you go to the National Instruments website, it will let you know how they're different. Andrew, could you explain what you mean by that?
So like, say you wanted a transistor model or a JPEG model that is currently not in Multisim. So, and I don't believe that Multisim supports directly the building of models like PSpice does.
Correct, correct.
Do you have a
So
workaround for that?
I do not. Well, no. No. The best that I was able to do when we had something that was not, when they didn't have a specific component, the best that I could do was, and it happened with, and it happened with FETs, was to look for one that had that was close. I wasn't able to create a new one, and if someone knows how to create a new one, I'd love to know. But that I've not discovered how to do. So when we had something that was different than what was on the list, then I just had to find something that was close for the simulation model. Now, to be fair, the models within the experiments that are in the experiments manuals for the digital book, McGraw Basic Electronics, electronic principles, are all standard component values. So all of those models are in a Multisim. So if you're using those experiments manual, all those parts are in a Multisim. If you're doing something different, then no. Any other questions?
I don't see any more in the chat. Few additional comments that I think you'll see, but But yeah, I wanted to thank everyone. We are, I'll stop the recording now too. And we are